Dear DSA students, we are so excited to be on this journey with you, and we want to say a big well done for your commitment and enthusiasm so far. Whether you have just joined or you have been learning with us over the past few weeks, we see your progress and we are rooting for you all the way. Now, we know there's been a bit of silence around the learning management system, and we sincerely apologize for that. But here's the good news. We have an update as regards the learning management system, and it is one you'll love. Some of you may have been onboarded on the previous LMS, but want to ask that you kindly disregard any previous link, platform, or communication concerning that old system. We are officially switching to a new platform that you may be familiar with, Canvas by Instructure. For those new to Canvas, don't worry. A video tutorial will be uploaded to guide you step by step on how to use the platform effectively on our YouTube channel. You will also receive an onboarding email directly from Canvas by Instructure to help you get started. Please follow the instructions in the email and input your details to begin your learning journey on the platform. We are committed to making sure your learning experience is smooth, interactive, and impactful. So please, pay close attention to the announcements coming right after this video for more details. We are so glad to have you with us. Keep going, we've got this.
Yeah, good evening, everyone. I welcome you all again to this section, this English section. If you can hear me, good evening, good evening, good evening. Okay, from last section, good evening, live guide that gets on Monday. Good evening. Oladale Oguntunde, good evening. You're welcome once again. Damilare, Spirit of Flame, Good Evening, once again. I'm happy to see us, and I'm happy um, to be teaching us again for this evening. Yeah, good evening, Shegun Bello. Good evening, Blessing. Good evening, Simeon. They are all welcome once again. So, for this week lectures, Oluwole and Isaac. Okay, I think Oluwole has knows. Take us through the class on the models, processing, picking different type of models. So we'll continue from there, and then we also continue with week 3. Yeah, week 3 last week. Yeah, last week we missed something last week, so we will continue from there. Then I will try all my best in between section to be asking us questions, and then maybe you have one or two stuff you are trying to fix. I'll see if I can help you with that. Okay. So for today's class, this is just a brief introduction of what we want to do. Yeah, good evening everyone. Good evening, good evening. Regina, good evening. Elaine, good evening. You're welcome. You're welcome. So I believe our system is on. We're all with our system. The Anaconda Navigator system, and then you have opened your Jupyter notebook, right? So I believe we are ready for this class. We'll continue from where we stopped last week, and then we will do a little bit of feature selection techniques, and then by next week we should be training our model. We'll be training our model, and then we should build something. At the end of this class, I will be building a system showing us how diabetes can be predicted, right? That is classification 0 and 1. So let us fly. Let us fly for this class. So my name is still remain Blessing. I am AI ML engineer or data science professional. So the goal from this class today is to apply or to compare multiple feature selection techniques, which Oluwole have taught us, standard scaling, and then different feature selection techniques on our work. When I open my Jupyter notebook, I'll be showing us just a little architecture of how AI or how you build ML actually, because AI deals with data sets. So I'll be showing us a little architecture of how it is being done. So we apply and compare multiple feature selection techniques on the ability data set that we're working with and observe how they affect model performance. Then last week we stopped at handling missing values, which we are going to do with that for this section. We're going to be using feature scaling. I'm using standard scaler. I'll be asking questions on this standard scaler. I believe Oluwole have taught us and Isaac they have taught us. And then we focus on the target variable, the outcome, diabetes or no diabetes. Machine learning or AI is more, I'll keep repeating it, is more of data sets. We will need data sets for anything we want to use our model to do. Then for this class, we will be exploring correlative matrix. That is correlative matrix. We've done that last week, but I'll show us again in our code. We're using random features importances, not random forest. By next week, we'll delve into random forest. Random forest is an algorithm. Another form is a model. You can call it a model. Then we'll delve into select k-base. That is else class if. We're going to recursive feature elimination, then forward selection, and also backward elimination. All these are just feature selection techniques. The same thing as you are picking features, like you are picking the most important features. And when I mean features is you are picking the most important um will I say attribute or something that will affect something. For example, we're working on diabetes. What are the things that you think used to cause that cause diabetes? Right? I think my first class, someone said sugar, then glucose, age, blood pressures, and then all the things that used to cause diabetes. So, but in data science, we call it features. Features. Then I think the number of rows is um, instances, right? So this does the basic feature selection techniques that we'll be using. Correlation matrix, random forest feature importances, select the best scales, RFE, forward selection, backward elimination. I love using forward selection and backward elimination. Actually, I love using it in my work. So that is what we'll be doing for this class. Handling missing values, feature scaling, then applying this feature selection on our work. We'll continue from there. So let's open your Jupyter notebook. Everybody open your Jupyter notebook. Okay, someone say insulin. Lucas, thank you. Open your Jupyter notebook. Everyone, that is Anaconda Navigator. Go to your Anaconda Navigator. I know by now we should have, every one of us should, your system should have been set. Then we'll continue from where we stop. Right? Just continue from where we stop. Let's start writing your code. Then we have, I don't know if they should have send the link to us for this new week, but it's just continuation, week 4, continuation of where we stopped last week. And if you are smart enough, I believe each and every one of us is smart, but if you want to learn further, don't just use diabetes mellitus data sets. Get other data sets. Get other data sets to work with. Right. So good evening. Is it Pampa? So everybody, if you are on your Jupyter notebook or you have opened your Jupyter notebook, please, in my class, I like hearing yeah yeah. So I want to see it in the comment section. Yes, yes, or yeah yeah. Anyone? Open your Jupyter notebook. Let us fly. Okay, thank you. Yes, Francis, thank you. Thank you. 80%. I'm not seeing the total number of people that have joined the class already. I want to. Yes, yeah, yeah, yes, yeah, yeah, yes. Thank you, thank you, thank you. Loading, Abimbola. Okay, that's no problem. Alicia, yes, yes. Okay. Okay. Now, that's for that. So while we are opening, while I'm waiting for others to open, I want to see the comment section. Yes, yes. So again, I'm saying this before I will change my screen to Jupyter notebook. I'll be saying a lot of stuff, right? And then this is what I do. I love it. I love working with this stuff. Then I'll be saying a lot while I'm talking. If you can still come back to listen to what I'm saying, because I'll be just saying little bit secrets of how you run your pre-processing instead of going through long process. I'll just tell you what to do, small stuff. I'll be saying it small. This one is meant for this one, this one is meant for this one, right? So please make sure you listen. Loading. We have two type of diabetes, mellitus type 1 and type 2. Insulin insufficiency and type 2. Docas Atta. In a real sense, we have three types of diabetes. We have type 1 and type 2, but in real sense, we have three types of diabetes. I don't know if you have heard of gestational diabetes. Gestational diabetes. Hmm? It's a diabetes. Okay, so let me share my screen. Stop this. Yeah, mostly for pregnant women. Yes. Yeah. Whether the person like it or not, you have diabetes. I make sure some people do their research. Yeah, there's one very problem. Yeah, that's great. Induced diabetes. Awesome. Awesome. Windows. Correct. Share. Victory. Correct. Okay. So, yeah. So I think I'm sharing my screen now. Okay. Thank you. Yeah. Good evening, everybody. Good evening. Still good evening. As you're coming in, open your Anaconda navigator, then Jupyter notebook. Make sure you open it. Jupyter notebook. So I'm waiting for the screen to come up, my own screen to come up. Then we do something. If you can see my screen, say yeah, yeah. Okay. No. It's coming up. It's coming up. Can you see my screen now? No, no. What's happening? Admin, please, if you can hear me, help me with my screen. Admin. Yeah, so it's coming up. It's coming up. Adiremi. Seeing yeah, can you see my screen now? Mhm. Okay, we'll see it soon. Yes. I don't know what's happening. No, I've shared the screen already. Um, I've shared the screen already. Okay, Mr. Emmanuel, I've shared the screen already. I don't know why it's not coming up. No, it's not idle. We have a lot to do tonight. We have a lot to do tonight. A lot. DBC, why do you say you can come up? Restart my system. I know. I don't think that's the issue. Let me share it again. I can share my um same thing. My screen is not coming. Hmm. The devil's a liar tonight too. Oh, and I can share my screen. I can see the screen is already shared here. Hello, admin. If you can hear me, please help me with my screen. I don't know. Oh, yeah. So Thank you. Thank you, admin. Can you see my screen now? Correct. Thank you. Thank you. Thank you. Yeah. Correct. Yeah. Let's use AI to detect the error. Am I right? I'll do that later. I'll write the model. I'll write the code. Correct. So, welcome once again. Welcome everybody. Welcome. No problem. No problem. So, yeah, welcome everybody. Welcome, welcome, welcome. Thank you, thank you, thank you, thank you. So, for some of all that I will system, I'll be explaining a lot of stuff. I'll be, saying some stuff in because the time frame for this class is too short. But I'm trying all my best to make sure we pick the most important um information, some important stuff we need for this class, right? So, and we've talked from the first class, we talked about diabetes mellitus, right? Then I said I'm interested in diabetes mellitus health. And from the first class, I said, why are you learning ML and then machine learning models, ML and likes? Artificial intelligence is the oga pata pata of them all. The tools that you need is machine learning. We also have another type of tools again for artificial intelligence is I will zoom spirit flame. I'll zoom it. Another type of the another tools we have for artificial intelligence is deep learning. Deep learning. So if time permits, we are going to go into deep learning. That if time permits, deep learning is more of feature extraction. But when we're talking about machine learning, most times it's feature selection, feature engineering, feature selection. Oluwole, Isaac, they've delved into it. So this is more of particle. Then again, in the first class, I said that anything you are doing, um, okay, anything that you are doing in machine learning or artificial intelligence, most times you need a data set. You need something to feed something, right? So I believe that because machine learning work like the brain most times, or deep learning, it work like the brain. You want to do something that will be working while you are tired, something that will predict, that will detect why you are tired, right? So that's for that. And again, any data set you are working with, make sure you do a little bit of research on what you are working with, what you are working on, right? So I've I've discussed, we talked on on that, talked on that. Yes. So now, we've seen last week. I still want to we'll continue from week three. Continue from week three because we stopped at for those that are following last week. We stopped somewhere, and then we've talked about the problem statement of what we want to solve. We want to detect diabetes mellitus early. And why do we want to do that? We want to create a system, develop a system. By next week, when we are splitting our data set, we split data set into 80, maybe 20, 70, 30. Many of these data set is you have a particular data set for training, we have another particular data set for testing. That is, you are separating them, one for training and one for testing. Now, when you are done with the training, you now test the model. So if the model generalizes well on training, you should be able to generalize well on testing, right? So when we are done with that and we apply our models, we'll be talking about models. We'll be talking about models next week. We'll apply different models. Then you will now be seeing reason why we are doing preprocessing, feature selection, feature extraction, feature engineering, while we are doing EDA, you'll be seeing the reasons, because every model have their own style of preprocessing, right? They have their own style of preprocessing. We'll be looking at that maybe next week. So, but for this class, it does more feature selection, then clean our data set, then do feature selection. Now, when we are done with this, we want to create a system, a model. So, data science or machine learning is wide. Artificial intelligence is wide. You should be able to create something like a system that people can come to your system, or a Flask, maybe a web framework using Streamlit or Flask, right? Now people can come to your system and check, oh, I'm working on agriculture, but I input so. This thing give me this something. Where by your AI, whereas your AI, your model is doing the work, is doing the background job, is doing everything in the background, right? So we'll be doing that. So last upper week and last week, we are doing this one. We taught you how to import pandas, and we've download all our models, import pandas for data sets, import our data sets, NumPy. Please zoom your screen. I've zoomed it enough. It's clear here. I don't know. Is it possible to zoom your slide just one more time for the sake of those using mobile phone? Okay, let me see if it can still work. Zoom on. Can you see it now? Is it okay now? Is my screen zooming off? Is it okay? Are we okay? Yeah, we stop at boss plot and the south. I'm just doing revision. I'm doing revision. Okay, thank you. Thank you, good today. Thank you, John. So it's okay. Yeah, thank you. It's good stuff. Okay, so I'm just doing revision for those of us that are still struggling with your the libraries. Still want to know about the libraries. Just revision and move forward. Okay, thank you, briefly. So I'm good to go. So we've seen import pandas, import NumPy for numeric data sets like arrays, to convert some of your data sets to arrays, because your majorly arrays, your models listing tool, or the love is 0 and 1 arrays, convert everything to arrays. Then matplots to plot bar charts, or these EDAs. We've seen that. And then we've also we are using WD simulators. Then df.ed. Now, what you do for me is make sure you are running this. We are going to that. We stop at none number also. None, replacing 0 to none. I'll be explaining that. So make sure you are running this one by one. Make sure you are running it to that place. We've seen shape. What about those of us using Mamba? What is Mamba? Sorry. So make sure you run your code to the last part where we stopped. We've seen this. We've worked with the outcome. I think I was like, I want to know the total number of people that have diabetes and people that don't have diabetes using value count for EDA, right? We've looked into it for EDA. Total number of people that have diabetes and people that don't have diabetes. So everything we did last week was EDA. Then we are now going to this week stuff. That is the none that I stopped. So last week, 500 people do not have diabetes, 268 have diabetes. Let me run this cell. Did that. Then import Seaborn. It's for visualization. So I want to see this in bar charts, right? I want to see it in my bar charts. Then we've done all this. One is, I think I still need to reduce this a little bit so that others can see. Outcome is not a variable. I said outcome is a target. Francis, outcome is a target features. The target features. I think I've explained that. Sure. But we'll share that with you. We'll share that with you. So I'm going to the last place to show us the where we stopped. Then we've talked about its map, right? Correlation matrix. Though we are doing that again this week. Correlation matrix. Then pregnancy against outcome. Glucose against outcome. Blood pressure against outcome is very, very low. So correlation, its map is just showing the eye features. Somebody messaged me on LinkedIn and the person was like, wow, thank you very much for explaining correlation to us. Now, if you are working with any data set and you don't know the type of features you want to use for today's class, I'll get to today's class, is feature selection techniques. Feature selection means picking the most important features that is affecting what you want to solve, right? The most important features. So when you're using correlation heat map or correlation matrix, you just look for the one that have high features against your target variable. Our target variable here is outcome, which is 0 and 1. So the high features for BMI is 0.29. I think some of those, you gave me the answer last week. The next one is 0.47, 0.22. There's inside too. You can still look, start to. There's still high features inside. For example, age is 0.454, 0.54. When I use another type of feature selection techniques now, you discover that it's just like an algorithm. It's a library. That's one thing. That's one good thing about Python. It's a library. You just write the code and it will tell you, you just pick it. So features will affect diabetes. So it's very, very simple and is unique, right? Very, 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 very unique. Very, very, very unique. Python is the most simplest programming language. There's libraries. Just anything you can think, you can code. Just look for the libraries, put it there. I need so. You're good to go. Right? Yeah. Thank you. Thank you for answering questions for me. And we have done this. So please run your code to the last part and let us now move to where we stop. Go to where we stop. Now, for the last class, we said something. We said that that when you visit or you look at your data set, you won't see when you're seeing a zero or you're seeing space inside the rows. Woman will always do mistake. Like when they're typing all this information, they will always do mistake, right? Like for example, when we look at df.ed, we saw that there are columns that are filled with zero. Imagine you visit doctor and doctor is telling you that your glucose level is 0. Like something is happening, like there's an issue there. Like there's an issue in that part. So now for this class, what we need to do is we want to replace a 0 with NaN, right? Not a number, like I say, not a number, NaN. We want to replace all those columns with NaN, right? So if you are with me, we are creating a variables, invalid column, then you are picking the most important features that will affect diabetes. First thing is glucose, blood pressure, skin thickness, insulin, and BMI, right? Glucose, blood pressure, skin thickness, and BMI. Can you see my screen, please? Please, can you see my screen? If you can see my screen, say yeah, yeah. No, those people are already typing already. Yes, okay, thank you, thank you. Just these two people, okay. Francis, thank you. Okay, so we want to replace a zero with none, non-value. Now, I'll be teaching us one secret. I'll be teaching us something today, right? And how Oluwole have taught us how we can now do the mean value because we'll be using imputation. We'll be using imputation in our code, right? Imputation is applying the mean, applying the median, right? So you're writing this code out, invalid column. You can name it another name. You can name it T or remove. Anything, just name it remove, but make sure that anything you name it here, you are also using it here. So what this code is doing is, please pick just this column for me. We have nine features. The glucose that cause diabetes, blood pressure that cause diabetes, skin thickness that cause diabetes, insulin and BMI, body mass index that cause diabetes. Now, pick it for me. This one is now saying replace a zero with NaN in selected column. So anywhere it sees a zero, it will replace it with NaN. It will replace it with it, right? So somebody will be asking me that why are we replacing a zero with NaN? That is machine learning for you. You can't just feed in a zero to your model. It won't accept. We need this NaN. That model needs to see this as that there's nothing in this column. There's nothing in it, right? There's nothing in the column. I still need to zoom, okay? I've zoomed the last zoom, Okay. Yeah, thank you very much for answering the question. So I'm trying to reply. So, okay, so it is replacing it with not a number. In the new week, we'll be looking at that, the full meaning of any, not a number, replacing that. The model should see that there's no number there. So after it replaces it, the next code is telling me, is showing me that this is the total number of zeros in each column. So now um when I run this code, when I run it now, it's showing me okay, I've run this code before, showing me the total number. It has replaced it. Then depth dot add, I still need to see what I'm doing. I've been running this code since I've not closed my system since last week. So I'm not seeing any none. I'm not seeing any non value. So I need to restart my kernel and run again. So if anybody is having issues, I'm going to restart my kernel and run this again. Can we use none that we stated in the comment? Will it work? What comment? What comments? I'll share with you. Yeah, I'll share my code with you again. No, no have time today. Oh. I'll share my code with you. Then I'll go to, after this one. After this, replace our non-value with zero with non-value. Then we'll go to feature selection. Right. Yeah. So okay, I think the code is working well now. So if you are still typing, type fast. Now, so what this code is doing is I'm replacing a zero with not a number. So the model should be able to tell me that we don't have number in this place. Someone is asking me that the last section is in your comment is model selection. Yeah, we're doing model selection. We are not done with last class. I can't just fly to model selection. I just fly to model selection. I'm like, what is happening? And you're just applying your code, your data set to your model like that. So we need to take it step by step. We'll get to model selection maybe today or next week. So my own class, I'll take it step by step. You need to understand how you clean data sets, do your EDA, feature scaling, feature selection, and everything like that to model selection. My next class will be doing fully model selection, right? So that's what we're doing in the next class. So now this telling me that we have the total number of is zero in pregnancy. There's nothing there. The total number of glucose is 5. It has replaced with noun, not a number. It has replaced with not a number. We have 35 is zeros. 35 is zeros in that column in for blood pressure. It has replaced it with not a number. We have 227 in that too. It has replaced it, that something is missing there. It has replaced it with not a number. So when I now try to look into it, normal, if it is me writing this code, nothing concern me with using dev.h again. I just know that in my own way it's already doing it. So when now try to check again if it has truly replaced it, you will see this insulin. It has replaced a zero with not a number. Replace a zero with not a number. Replace a zero with not a number. Now I'm scrolling all back. I will scroll back. Zoom. Can you see my screen? Can you see my screen now? You keep saying I should zoom. Yes, you can have it. Can you see my screen? I've zoomed. Can you see it now? Is it clear? You can see my screen, say yeah. Okay, it's clear enough. Thank you. So as someone said, I use none and it's giving me none here. Yes, it will change. It will still change to this. Another way it will change again is it will be inside brackets, right? So most times it's always be the first thing is capital letter N, small letter A, and capital letter N. Either use the big letter or use small letter, right? So this part of preprocessing. This part of preprocessing, right? Then I still want to check the tape. Now let us be sure if this is real. Let us be sure if this is real. When I first run my code in the first place here, and I check the dot head, you will discover that this first one here is swing is zero, is zero, is zero. This part two is zero. When I run the dot tail two, it's still the same thing. Is zero, is zero, is zero, right? Now, what that code is doing for me, when I now replace it, I'm scrolling back down. You have done all this one. I believe you should not be confused. You should not be confused. Don't be confused. Don't be confused. Yeah. So what this code is doing for me now is it has replaced zero with none. It has replaced zero with none. So if you have run your code and it's showing that, please, I want to yeah, I'm not getting the same result. What are you getting, sir? Mr. Babs. What are you getting? This is the code. I want us to run it. Everybody must run it. I'll wait. We know we just feature selection we want to do today. Then we'll do model selection next. Just feature selection. I'll wait for us. Everybody must get it. Okay. You. Some are getting it. If you're not getting it, Bas, what's the problem? Okay, thank you, Joshua. Check your code again. Name error trace back, most recent call, line 1. There's an issue with your line 1. DF is not defined. DF is not defined. That is to say, go and run your code again from top. Mr. Abiodun, go and Salami, go and run your code again from top so that you define DF. DF is a variable that you declare. You thought of variable, you declare a variable like DF, hold my data set. You can also say Salami, hold my data set for me. But I'm calling this my data set fire, or I'm calling my data set fufu. I like using food, right? So anytime you want to now make use of it, you discover that anytime I want to make use of the data set, I'm now calling the fire, or I'm calling fufu, df, so, df, so. So go and run the code again from top. Make sure you run it from top to bottom. Yeah, thank you. You need to install the necessary libraries and define df. Okay, thank you, Emmanuel. Thank you, Emmanuel. But we can also change df to anything, like you are declaring a variable, attaching something to something. You can say Benny, you can say Emmanuel to something. Yeah. Repeat it from beginning. Stage executive. Time new. If I can finish today's class, I will repeat everything. Stage executive. If I can finish today's class, I want to make sure I finish today's class. We will continue. Pam, you're confused. Why are you confused? Don't be confused. Have you been following our class? Other people are getting it. Have you been following our class from beginning? Please, stage, remind me again. If I can finish this class, just remind me. I'll just do like a workshop. Thank you, Emmanuel Izishi. Thank you. Yeah, thank you, Adeleke. Thank you. And what result is he giving you, Babs? What results? Let me know. Yeah. The last line is not clear. Check how missing value are now present. Okay, that's what we know. Correct. Thank you. Yeah, Mr. Abiodun. That I was actually waiting for you. We've been running from the beginning. Yeah. Isaac, what is your own replacing it with? I want to know. Just please zoom in, sir. I've zoomed into this is my last zoom in. Don't just tell me that it's not working. I want to know your error. Just give me the error. I'll tell you what the answer. Okay, so, or you can screenshot. Oh, sorry. No, just tell me that this is what you are getting. I'll give you the answer. I can't see step 5. Please, what document are you using? Are you all using? DF is not defined. Thomas, seeing DF is not defined means go and run your code from top. Go and run your code from the beginning. You are not getting error. Yes. Okay. The none. What type of none? What type of none? Okay. While we are doing this, let us continue, please, because of time. I want to make sure that everybody we are working together, we are doing this together. So now, is 0 have been changed to none, right? Is 0 have been changed to none, and then yes, that be changed to none. Anywhere you see is 0, anywhere you see is 0, it is now non-value. Now we want to do imputation. You can't just leave the non value there, right? For example, on a column, this column, We have none, 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 156. None, 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 156. Now look at how mean work or median work. In one of my paper, what I did was I used mean for my paper, and I applied the feature selection I applied was forward and backward feature selection, right? None, none, and then apply mean value. But imagine, as I'm a researcher, I keep saying it, I'm a researcher. While I was working on this thing again, like, oh, I want to make sure this thing people understand. I discovered that the best stuff I should have used, though that paper was published in one of the best journal, right? But and I discovered again that one of the preprocessing techniques I should have used is median, right? So now this is how it works. We have for this column, we have none, 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 94.0, 1680, and the likes. So how can we fill in this column? Because we can't just take none to our model again, right? We have to first thing first is change the 0 to none, or another thing again is some places that there needs to be 0, some column, it will be left empty. So most times what you will do is you remove the column. You remove the column. When we start giving you assignment on the morning given of data set, you understand what I'm saying. I'm just taking my time to make sure you understand. This what I'm doing today is just one part. Let me say 5 parts of ML, 5 parts of ML, but it will help you, right? Now, looking at this, we have, let me see zoom. We have none, none, none on one column, 156. See how we are going to do your imputation. For me, see how it is going to work. If we forget not a number, so anytime you're running your algorithm, you just leave this not a number alone. Then to pick where there's number 156. This is it, 156. Divide it by the total number of the column, like the total number that is inside, right? So the many number that is inside is 156. When we divide it by it, it will now be 4.0. So if I'm applying mean to this column, where is not a number, if I'm applying mean to this column, it will change it to 4.0, right? So I'm not using mean now. It's just a simple code that will do that. I'm not using mean. I will not be writing mean for each column. No, just one single code, just one single column, just one single line of code. We replace that, right? So if you fill none using mean, this is what's going to happen now. 4.0, 4.0, 4.0, 156, right? 4.0, 4.0, 156. That is how the mean is going to. That's how you're going to fill in. We call it imputation. It's the type of preprocessing techniques in our work. Again, we have for median. So what is median is going to just do? It's just going to pick 156. Then there are 3 values: odd number, median numbers, and median number. You just pick the median number. Median is median number. Oluwole have taught us, Isaac have taught us. You just pick the median number. I'm taking my time to explain preprocessing. Last week was EDA. This week is just preprocessing. Before we start going deeply into models, preprocessing. That anytime you just see one code and like, how is this thing working? This is how it works, right? This is how it works. You just pick the middle number and fix in with a none. That you just pick it and fix it with a none. So this what data science is more of cleaning messy data, actually. More of cleaning messy data sets. You clean, you redirect, you destroy. I'm working on the project presently now, and then on breast cancer. I think I said it in my first class. Breast cancer destruction technique, breast cancer. We collect the data set from one hospital like that. I don't want to say the name of the hospital. Now it took us 2 years to collect data sets. Now we are using like 6 months. 6 months now. This is 6 months. We are still cleaning data sets. Applying enhancement technique. That is a deep learning model, enhancing, cleaning data set, arranging the data set, and the likes. So if you are done with cleaning data set, then you now know that, oh, this person is a data scientist, right? So That is what we are doing. When do you use mode? When you use median? I will answer that in the next stuff. The document is not spread through. Okay, we'll be doing that inputter from SKLN. Yeah, correct. So a normal distribution look like a bell curve. I think I show you this stuff. A normal distribution look like a bell curve, and then this is just like a normal distribution. This is a normal distribution. We have 165, 166, 117, that they are related, they are together. The data set is scaled. Most times when they want to do close level, the scaling. The mean is around 169. When you calculate this stuff, same thing for now. We're looking at skill data set. No, we're not doing that. I'll use code to do that. Skill data set is when you have 2, 2, 2, 3, and something is now far away, 50. The skill data set. Right skill, left skill. I've taught us this last thing. Now, there's something here. Data look balanced. Normal curve, use mean. When your data look balanced, in normal curve, you use mean. But when the data set is skewed, pull left or right, you use median. Right? Outliers are present, you use median. Now, our last week stuff, we did EDA. We discovered that there are outliers, right? A lot of outliers. Even before we start cleaning, there's a lot of outliers. We send the code out. There's a part I had 1 or 2 code again that to still clean more outliers. We can run the code and do that. So when your data set is skewed or it has a lot of outliers, you use median, not mean, right? Use median. But if you are now like a professional, you should be able to use mean, right? So I said one of my paper that was published in one of the top journals, I use mean for. Now, to replace all those stuff now, all those NaN with median, you want to do inputter. To replace them, this is the code here. Just try the code now. The next line, everybody, the next line, you are with me, df fill now, df dot median. We're not using mean, median. df median, then in place true, you should be equal to true. Try the code. Then when you are done with the code, when you are done with this code, you now open another cell and press and type df.add. Now look at it. Check if the NaN value has removed. Then if possible, if you want to calculate, do your calculation. You can do your calculation. But this single code, that's why I like Python. This single code has covered up for everything. No need of doing calculation one by one. So every place that there is 0, NaN, it will replace it. Right? It's going to replace it. So can we try it? And if you are done, just say yeah. Because we'll be going for break. So I will take attendance, then we'll continue with feature selection. Then we are done for the class. I believe I want to be fast today. I want to be fast. It replaced the NaN with 125. And Godwin, that is good. That is great. Replace the NaN with 125. Then we do DF.9. That's why are we using 2? It replace the NaN with 125. Yes. Okay. No. What is something we are writing the code? It's not, we are not replacing target value. Target is already okay. So what the code is going to do is anywhere there is NaN, it will fill it up. Inputter, that's one inputter. It will fill it up. So everything we're doing is data cleaning, data preprocessing. Simple. Now I can send 1 or 2 jobs to one of you here. Can you please do so? So can you please clean this data set? That's what we are doing. Right? Then we'll continue with, okay, I think it's time for break. So if you are done, okay, yeah, thank you. The NaN was replaced with 125. Yeah, some of you, it's going to be 125, 125.0. Some is going to be just 125, 125.0. Some is going to be 125. Right? So that is great. Olashade, thank you. Correct. Yeah, that is great. That is great. That's awesome. Okay. Um, awesome, awesome, awesome. Please take your attendance. I don't know. I believe this thing should just go off because it's supposed to be like 5 minute break. For the next 5 minutes, please take your attendance. Everybody take your attendance. Now change to 1 to 5. All now take 1 to 5. Correct, correct. If possible, you want to do your calculation, sit down, do your calculation. I deal can do your calculation. But what I'm just trying to say is simple, one single line of code, one single line of code, we do the imputation, to do your mean, the imputation for mean, imputation for median. You want to apply, I don't know if you use mode, somewhere else for mode. I don't know if you use mode, right? So, and somebody asked for, he said, why true? Um, at least look at something. If there is median, anywhere there is none and it is true, replace it. Yeah, yeah, thank you. Okay, yeah, yeah. So we'll be back next few minutes. Time for break. Then we'll continue with feature selection techniques. So Yeah. Welcome back, everyone. I believe we all fill our attendance. Okay. My zero fuse changing to none. The code is copied from cargo. The code is not copied from cargo. Okay. Some of you get 125, 125, 125, 125. Okay, correct. Awesome. So we have just successfully um um apply processing techniques on our data. Now we've just used um median, not mean, median on our work. So if you look at our data sets now, everything have changed. There is no missing value, nothing is missing again, and it's clear. We're able to go, can apply it on our model. Now, the next thing is applying, picking the most important features. Most times, sometimes you might want to use all the features, right? You might want to use all features. And sometimes you might just want to pick the most important features in your work, important features in your work. So we have done this, and then okay, filling missing value with mean there filler, then we work and it will replace the non-value. But here's the key difference. Method work best when handle appliance. Mean data is normally distributed, bell curve, median data is skewed or has outliers. But because our data, some of our data have outliers, we use this. There's another way I can clean my data set. And there's another way I can clean my data set because sometimes me, I want to be bent on using another stuff. So, you have to just be thinking, okay, what if I did like this? What if I did like this? Because when we start using our model, and I've talked about all these, then look at the shape. I've talked about this. Now, for today's class, talk about all this. We've done all this last week. Yes, all this last week. So week 4. So I'll tell us where we'll continue with our code. Actually, I'll tell us where we'll continue from with the code. Right. So I've zoomed. Spirit aflame. I've zoomed. I don't know if you can see my screen. I've zoomed. I've zoomed it. Now, one thing about machine learning or AI is this: you get a data set. This does a simple architecture, right? You get a data set, then you do data preprocessing. My assignment for us is go and learn different type of preprocessing techniques, that okay, Mr. Blessing taught us using inputter, like using mean, using median. When there's outliers, when there's no outliers, you can use mean. When there's outliers, you use median, right? Okay, are there any other type of preprocessing techniques that I can apply to my work, right? So that is my own assignment. In your leisure time, you can play with that. Then another part of preprocessing again is feature selection. I used to call it another part of feature selection, but it's another unique way of picking the most important features. I keep saying it, picking the most important features before you do anything, before you apply it to your models. Then when we are done with that, you do model training or model testing, model training and model testing. I'm putting something here as assembly model. I'm not supposed to put it, but assembly model is it is combination of 2 or more model. So when we're talking about model, we're talking about algorithm. When we're talking about algorithm, we're talking about a function that somebody have developed. Somebody have trained something or something, develop a function and call it a name. The combination of plenty functions. Like it's an algorithm, right? We're talking about all those stuff. Then combination of all these things together to call it assemble or hybridization. Then after that, we'll be doing model evaluation. That's next upper week, we'll do model evaluation. But for today, we will be just focusing on feature selection. And in one word, feature selection in sentence, feature selection is picking the most important features I keep repeating it. The most important features that you want to work with. A simple line of code or a single algorithm can do that. Just a line of code can pick the most important features in your work, right? Then I said we are going to be developing a system, an interface or application for our work. Very, very simple. We'll do that maybe using Flag or Streamlit, right? So picking the most important feature, when we're talking about feature selection, we can use correlation matrix. I taught us last week. Correlation matrix is just EDA. So it's a measure, it measures linear relationship between features and a target, the features and the target, right? And also help visualize which features are strongly correlated with outcome. Then another type of feature selection techniques that I can do is feature importances. So for feature importances, normal feature importance can stand, but the best feature importances is using random forest feature importances. Random forest is a model on its own. But when you're saying random forest feature importances, right? So it's another type of feature selection that is used to train a random forest model to assign importance scores, capture both linear and non-linear relationships. Then another type of feature selection is select k-base. Select k-base. So select top k features using on the right statistical text. That is, I'm using ANOVA F test, right? Using ANOVA F test. I think some of you have know about statistics. So don't be scared though. Don't be like, this one has been, you are seeing ANOVA F test, you are seeing select something. Don't be scared. I will make it simple for us, right? That are different type of feature selection techniques. Your own is just two. Your own is just two. I used to say, anything you can think, you can code. Your own is just, okay, this type of feature selection techniques. Then go online, do your research. What line of code do I need? Just go and just look at the line of code. Okay, this line of code, apply it to your work. Then later, start looking at how does this thing work? How can I use it? Right? Okay, so that is what you need for this. Then another one is a recursive feature elimination. Recursive feature elimination is I think is more of is under forward and backward feature selection techniques, and then that is under wrapper method. Because when I was doing one of my work, I discovered this recursive features elimination, and I now discover wrapper method. Under wrapper method is forward and backward feature selection techniques. I know some of us would like this forward and backward feature selection techniques, right? Some of us like it. So what this one does is you pick the model from the front. You start with no features first, add the best one at a time. Then the backward, start with all features, remove the worst one at a time, right? And remove the worst one at the time. So one unique thing about this forward and backward feature selection techniques is they pick the most important features. If you select 4 here, like this one should be 4, this one should be 4, they will pick the same thing. They work hand in hand. So when you do forward feature selection techniques, test it with backward feature selection techniques. If it is the same features, it pick, right? If the same features, it pick. So that's what I want to be doing for this class using Miss Tailed and Light. So again, we've seen our libraries, import pandas as PD, import numpy as NP, and import matplots, lib as pyplot as P for our visualization, arrays, pandas for your data sets. We've seen all this again and again. Okay, let me look at the comment section. Pam. Missing value outliers and the proper description of the data. Apart from this, are there any other things we need to keep in mind during the process of processing data for model training? Yes, a lot. There's a lot to keep in mind. Apart from outliers, there's a lot to keep in mind. Please, do your research. Then before you are done, get back to me. Do a lot you can keep in mind is normalization. Then there's another thing again in deep learning that's called feature extraction. Feature extraction, the most important features too, apart from alignments and missing values. And then, yeah, for now, I think it's missing values, outliers for now, but there's a lot actually. So do your research. What happened to network? Nothing was network. Okay, so yes, I did Dayo, but stepwise, progressively, stepwise, backward elimination. I think yes, stepwise. I applied that to one of my work. Okay, so within people processing, we have replaced it with none, and then I love the response, love what everybody worked with. Imputation, filling it with mean, median. We've done this. I like using those to check my work, to check if there's non-value, then replace it with zero, replace it with zero, then the data dot head. So now the step three, we'll be going to step three. Fisher, the step three is, I think it's going to be step 6 or step 7 in your place. We're going to be using Fisher scaling. Fisher scaling. And why do we do Fisher scaling? It is used to normalize, still need to normalize, like scaling. Oluwole have taught us how does scaling work. Scaling is, we want to bring everything that is still working with, like as if you are doing appliance too. It's still everything that is far away. We want to bring it together, let them be in one place. So by next week, when we're talking about different models like KNN, SVN, support virtual machine, logistic regression, random forest. Before the next class, everybody go and learn about model. Just go and read about model. Just put it online. Models. What type of models do you have? Or machine learning algorithm. You can say machine learning algorithms. Machine learning algorithms. List different type of machine learning algorithms. Then supervised. We have supervised machine learning and unsupervised machine learning. Okay, let me ask this question before I continue. What are supervised? Oluwole have taught us. What are supervised machine learning algorithms? What are supervised and how does it work? And unsupervised. Supervised and unsupervised. How does it work? Right. Let me see if we already know what we are doing. Supervised and unsupervised. From the class. Supervised ML is when you data are labeled, correct? And data are labeled. Eniola, I'm going to ask another question. And also supervised, they have features labeled. What of unsupervised? Yeah, okay, supervised work with labeled data. Correct, correct. You already know what you are doing. So that when somebody contacts you with jobs, we will be saying a lot of stuff. I'll be saying a lot of stuff here. When they contact you with job, you'll be asking what type of data set. If the data set is messy, it's unsupervised. So you are the one that will want to be supervising the data set, right? Supervised work with work with data train on. Okay, supervised learning is when you train a model using labeled data. Labeled data. Naturally is a labeled data. What of unsupervised? What of unsupervised? Unsupervised learning. If the data is not labeled, the data are not labeled. No labeled. Unsupervised learning model is machine learning analyzed on labeled data sets to discover the learning group and interpret data based on only input data. Okay. So we are already preparing for the world. We're already preparing for the to be a machine learning engineer. Machine learning engineer, I keep saying is you're fine tuning, you are training a model, you're training a model with a data set, right? So supervised is labeled data set. Unsupervised is not labeled data set. Last question before I continue. The ability similarities data set we're working with, is it a supervised data set? Like, yeah, okay, how should I put the question? Is it supervised or unsupervised? Okay, yeah. Is it supervised or unsupervised? The data set we're working on with now, is it supervised or unsupervised? Good, good, good evening, sir. Yeah, think you're welcome. Supervise. Godwin supervise. Is supervise correct? Why is he supervise? Why is he supervise? Is it Adishewa? Is this Adishewa? Felicia? The teacher giving a maths question. Yeah, correct. Correct. So why is he supervise? Why is supervise? This labeled, that's labeled features. Correct. 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 Now, apart from it has a labeled features, it has a target variable. It has a target variable, right? That's an outcome. Yes, we want the model to predict. Correct. Yeah, baby. That's the data variable. The outcome indicates the label. Yeah. Otun Yetunde. Thank you. Thank you. Yeah. Data set is labeled. Correct. Yeah, correct. That's why it is supervised. Most data scientists or most machine learning engineer, they like data set that it is clean. They love it so much. Like just do simple people processing, do what you want to do. But the real data scientists, you will clean a lot of data set. You have to understand data set. Now start cleaning. This is what I want. This is the folder I want to put it. This is what I want. This is how I want it. So I love this answer. A Adebisi Emmanuel, because we got it from Kaggle. A data set you get from Kaggle that are not supervised. A data set you get from Kaggle that are not labeled. Actually, they are not labeled. Data set you get from Kaggle that are not labeled. Who no like better thing? You're Isaac. Likes all is well. Correct. So let's continue. I love this answer. It shows that we are flowing. It shows that we know what we are doing. Actually, now we need a data set that is clean, data set that is labeled before we do our work. So could you show us unsupervised data set? Yeah, most times I'll let me explain. Most times unsupervised data set does not have outcome, does not have target variable. And most times when we use unsupervised machine learning model or unsupervised is when we are working with image. That's why you will see image feature extraction. Feature extraction. You are extracting features. You are extracting your own features from the image. So the doctor have already, for diabetes mellitus now, the doctor have already, they sat down, they asked the patient information. What's your name? How old are you? Your blood pressure and everything. They have analyzed it down for us. But you are now doing it yourself. It's unlabeled. That's unsupervised. So you are now, there are models that can do that. CNN, deep learning models. This class is usually for machine learning. CNN can do that. It will extract features and it will now turn it to, it will extract it and turn it to label for us and give us the prediction, right? So from unlabeled data set in unsupervised ML, correct, correct. Machine learning tool extracts from unlabeled data set too, correct. But let me not scatter everything. So let's continue. So we have standard scalar. That's standard scalar. And I said that why model like KNN, CNN, and even logistic regression perform better when data is standardized. So when data set is standardized, eh, um, they perform better. Most times I don't use this, but I just like, okay, let me standardize my this stuff. So what this does is, please now start writing your code now. From sklearn.preprocessing import standard scalar. So this is this standard scalar. No need of the calculation that only taught us, or Isaac. We started saying x is equal to xn minus sw over n divided by something, and they are now normalizing. Well, we don't need that. Your own is just come to Python. Is there library for standard scalar? I want to scale my data set. Call it, right? Just call it straight. So from sklearn, you can type it down. Sklearn dot preprocessing import standard scalar. Then the target variable s is equal to df. Then do the outcome ASIC1. So what this ASIC1 is doing is drop. Where is this? How can I show us? Let me see. one. Please just make sure you type this code. I want to copy this out. S is equal to df drop outcome as is one, then y is equal to df outcome, then scalar, standard scalar s scalar is equal to s scalar dot f dot fit and transform x. I should be explaining this because of my time. I should be explaining this. Just do this. Just put the code down. Without time to rush. I promise somebody stage. I'll go to revise this thing again and again before we go. Maybe like 5 minutes. Right? No, it's not. It's not compulsory. It's not necessary. It's not necessary. This is just part of pre-processing. Actually, it's part of it. We have seen it from the library. It's not necessary. I just want us to have taste of different type of pre-processing techniques. Actually, right? sklearn library is a library for pre-processing. So that is to say, okay, when Oluwole was teaching us, or Isaac, you saw all those mathematics something, right? I'm answering Iga, is it Iba something? So all those equations, you saw them. So what this thing is doing, they have imbibed it like it's a function. Just call the function. So no need of doing the calculation again. You want to process, you want to clean, we are still cleaning, we are still transforming data set. Right? Please, I don't understand your question. I don't know if you can do that. So if you are done with that, please say yeah. If you are done typing, say yeah. I'm done typing, just say yeah. Just say yes. Yes. Run the code, just say yes, then we'll continue. For the feature selection, we'll continue. Then we'll call it a day. Yeah, thank you, Benny. Thank you. Thank you very much. We'll be sharing this link with you to practice it over and over again. Then again, we worked on the introduction to Python. Saw one link online, introduction to Python. For some of you that are new to Python, you can just play with it, play around it, and do what you want to do. sklearn is showing you there's no output when the code is executed. It's showing me no module name sklearn. Now, what is that is telling me that it did not install the library. It don't install the library when you need to install the library. It did not install it. Yeah. Data processing. Okay, so well, for some of you that don't want to do standard scalar, it's just a part standard scalar, just to transform data sets to make sure they are the same thing. If you don't want to do it, let us go to the next one because of our time. So I said there's different type of feature selection techniques. There's still more actually, but this is just the simple one that you can work with. We have random forest that shows the feature importance, correlation, recursive feature elimination, forward feature selection, and backward feature elimination. Now, this is how the correlation, and I said when I see correlation, you see essential, still coming back. Correlation is showing the I features, those one that are features with the target variable, 0.22, 0.49. Glucose to insulin is very high. Glucose to insulin is very high. 0.49 to the target variable, 0.31 BMI, and age is 0.24. Note this again. Now, when I now want to apply feature importances using random forest, I think there are two types of model that can use to do feature importancy. So this is a code for feature importancy. Import this one, then define the variable for random forest classifier, then fit it into sky, or you scale, then the importancy, all these code there, is for the importance. Now, what this code is going to just give me is pick the most important features from the top. So when I run this code, it's giving me the top is glucose. It has the highest features techniques, the highest features, what do you call it? Yeah, the highest features importance, followed by BMI, followed by diabetes predictive function and age, diabetic predictive function and age, followed by insulin, pregnancy, and blood pressure and skin thickness. From the data set, he pick the most important. That is just, I think we have 1, 2, 3, 4, 5, 6, 7, 8. But there's a way you can do it. There's this code in my week 3. We'll share something with you. Week 3, he just pick 4 for me. The glucose, BMI, diabetes predictive function, and age. Right? From here, even starting from my looking at my correlation matrix, I should have been knowing. I will have, okay, so features we affect diabetes. So I'm already noting it down to affect diabetes. Okay, but because I want to be sure, I want to do further feature selection techniques. I'm now applying feature importances. That which one again? Maybe the first 3 or the first 6. We saw that glucose, BMI, diabetes predicting function, and age. So these are the features that you will apply to your model, right? These are the features you will apply. You just pick the most, maybe the 6 or 4, just apply them to your model. And yeah, you need to be very, very careful, very, very careful. Like, okay, I just want 2. Glucose and BMI is okay. No. In your data set, there is maybe finance, so corruption, and so is okay. No. Very, very careful. You have to be careful because this is where the work is. You'll be like, okay, what if I use this one? What if I use this one? Will it cause this one? And like, when we get to accuracy, precision, F1 score, analyze, all this stuff, I will explain it. When we get to confusion matrix, TP, TN, FN, FP, false positive, two positive, two negative, all the stuff, I will explain it. I will use, they are all simple actually. If you know this stuff, you are good to go. I can even to this extent, like you are still putting to this extent, I'm already congratulating every one of us. You're already a machine learning engineer, right? So just try this code on your system, and see if it's going to give you the feature potency. So that's for this. Then for select K base. To select the K base. Now what this thing is doing is this K base is selecting 1, 2, 3, 4, 5, 6. Selecting 6 for me. Pregnancy, glucose, skin thickness, insulin, BMI, and age. Pregnancy, glucose, skin thickness, insulin, BMI, and age. Not 8 now, not 8, not 9. Just selecting that this will affect diabetes. These features will affect diabetes, right? And yeah, it affects diabetes. When I apply recursive feature elimination, when I apply it to, let us see what it's going to give us. But you will notice that all of them are picking something. All of them are picking glucose. They are picking glucose, blood pressure, BMI. All of them, almost all of them is high. This glucose is very, very high. All of them will have pick glucose. It's now meant to you, like it's now up to you, not meant to you, up to you. Now, like, okay, what did I want? Okay, most of them, all of them, this when I use these social features is speaking, this social feature is speaking. The best features you can use, feature selection is random, yeah, feature importances. Most times you use feature importances because you're going to use it in a model, right? So if you are with me, say yeah, yeah. If you are with me, say yeah, yeah. Let me run this. I want to just run this. I want to be rounding up. We share this code with you. I believe they will have sent it on a link, send it to you for you to work, play with it. SK is not defined. Okay, I need to go and define it. I've not defined it. Yeah. This is what I'm going to. I actually want to work with just for backward, forward, and feature selection techniques. Forward and backward feature selection techniques. Now, there's a part here that is it use logri. This is a library for forward and backward feature selection techniques. This is what you use, right? we barely get the slides to the class, only those of the first week. Okay. We're just saying yeah, yeah. Okay, thank you. So okay. So what this is doing is this where all this code here, log array, logistic regression, mass iteration to 100, that is picking it from the first forward feature selection techniques, is looking at the best feature selection, then to the last, looking at the best feature selection technique. Then this place, I just want 6, just pick 6 for me. Then when I want this code, it's going to tell me 6 features that will affect diabetes: pregnancy, glucose, blood pressure, skin thickness, BMI, and age. Then if I change this to 4, I just want 4. Most times I use 4. Change to pregnancy, glucose is still there, skin thickness, and BMI. But I'm not sure. Do skin thickness affect cause diabetes? I'm not sure. But it's picking skin thickness. What of if I use backward feature selection techniques? Feature selection techniques. Pick 6 of them. 6. Pregnancy, glucose, insulin, BMI, predisposition, and age. What if I say 4? I'll allow us to run the code though. Please don't panic. I will just show us the code. So you run the code. Then we're good to go. Okay. Pregnancy, glucose, BMI, and age. Same thing as this one. Pregnancy, glucose, skin thickness, BMI. We have BMI, pregnancy, glucose, skin thickness. Skin thickness here, skin thickness here. Pregnancy, glucose, BMI, age. Backwards is telling me only age. Only age is missing and skin thickness. So there's something that is wrong. That is wrong here. There's something is wrong here. So which one should I pick? These are the 2 of them now. Which one should I pick? These are the 2 of them. Sklen. Okay, let me allow us to run the code. Can you all for this forward feature selection techniques, can you just type this out and run it on your system? Type it out and run it. But make sure this one is 5. N features to select. Make sure it's 5. We need just 5 features for our work. So if you can see my screen, type it out in the next cell, type it out and pick the most 5 features I want to apply to diabetes mellitus. In the next class, we'll start with splitting our data set into 2 or maybe to 3. Train, test, validation. We apply to our model. Train, test, validation, and we apply to our model, right? We are not seeing on the code. How are you not seeing on the code? I cannot import sklen. It's suggested I run sk scikit-learn. Suggested you run scikit-learn. Try it. Try it. Instead of sklen, put slash in the middle. Yes, the IPR will be made available for us to run and work with it. So if you have done this, please, I want to know just is it showing clearly? It's showing. If you have run this code, I want to on the comment section, and I'll say yes, yes, yes. Skin thickness, also called skin toga. It's just a physical clinical features telling us the patient is dilated. In addition, it's just physical features in diabetic patients. Okay. Thank you, Shegun Bello. Thank you. Yeah. Zoom in, please. I've zoomed. The zoom way. Yeah, I've zoomed you. The same part that is even showing again. I've zoomed. Second paragraph. Okay. Let me scroll. Can you see my screen? If you can see it, just type it out. So what you do for me is please try to zoom. Yeah, if you can see it, just try to zoom in your own end. So you see all the codes together. This is just four feature selection. Just four feature selection. So let us see what it's going to give us. And I want to see your results. Then you apply backward too. Zoom it on your own end too. Just try to zoom on your own end. But if I zoom it, that forward will cut off. Yeah, we're sharing it. We'll share the code with you. We'll share the code with you. So if you have done this, please, yeah. Just yes, I've done this code and it's working. I've done this code and it's working. One of the error that one or two of you might be facing is something is missing. You need to install it. So go and install it sharp. You need to install it and download it on your system, right? Let me see. There's okay. This is also a summary of everything. Accuracy, precision, and the likes. You are done. Yeah. I'm waiting for someone though. I'm waiting for someone. In my next class, I should be giving out gift, free credit. In my next class, I think it's going to motivate us all. I'll be giving out free credit. Stephen Tayo, okay, yeah. Thank you. I'll be noticing you. I'll be noticing you now. I'll be noting you down now. Stephen Tayo say yeah. I will note you down. Godwin blessing. Yeah, I will note you down. I'm noting you down already. So if you can answer, I just say all this code and I'm doing it as fast as possible. And I'll give me the answer. Free credit. Please remind me of next class. Free credit. Emmanuel DBC, I can't zoom because of the forward. Try to zoom it on your own end. Try to zoom it on your end. What is before the forward? Direction. I think it's direction. Direction is equal to direction. I want us to try this code. Let's try it. Got it. Okay. No, we're not cleaning data set again. We're not cleaning data set. We are done cleaning data set. Joshua. We are picking the most important feature, the most important features in our work, the most important features in our work, then apply it to our model. Next class is model. We'll now start training model, fine-tuning model, and fine-tuning, yeah, adding one or two stuff to our model. So I note Godwin, Stephen, I'm not you. Ifeoluwa, thank you. Irene, Ayakazi, I don't know if I get the name right, if I pronounce the name right. We do forward the material. We do that. We send the material already. So I believe maybe you check your email or check your spam mail. Just check if you can see the material there. Page Collie, you can't see Psychic Lane. Page Collie, I would like to see your code. I would like to see the error of your code. Okay, yeah. Thank you, Emmanuel. Samuel, thank you. Yeah, just 15. Code 15 alone. Just 15 alone. And there's a reason why I said, yeah. Thank you. Thank you, good today. And there's a reason why I said you should do code 15 alone. Feature selection. I started with correlation. From correlation, you can pick your feature selection. From correlation, You can also use feature importance. Feature importance is just graph, just still EDA. So I don't want that. I want us to see tests again for using forward feature selection techniques, backward feature selection techniques. For some of you that are statistician here, forward and backward feature selection techniques is under wrapper method. It's a wrapper method under recursive, RFE. It's under recursive. And not necessarily you know this stuff. When you want to use it, just know that, oh, I need to ask. Just do your research. What is missing in so? And then maybe in the next class, I should be teaching us how to use LLM again. Sometimes instead of asking question or do rigorous research, you can just use LLM. That just go here, and tell you what to do. Right? Yeah, done. Yeah, thank you. Thank you. Like the yeah. Thank you. Thank you. Yes, I'm already I'm noting people's name down. Please remind me next week. Free credit. I don't know if I can do it, but I should be able to do it just to motivate us, right? So now that's for that. Um, so feature selection techniques is to pick the most important features for our work. Then this code, we change this code to, I believe they should have sent it. This code is just showing the summary of how feature importance for random forest worked, select K-best worked, RFE worked, forward, and how they pick the most important features in this work, right? How they pick the most important features. Then I shouldn't be explaining this because this one is for the next class. We're talking about accuracy, precision, recall, F1 score, and then applying Skillup to the work. So the best of the best, when I applied SK best is 0.75. When I apply RFE is 0.77, but random forest feature importance give us the best, that is 7597. See the same thing. See the same thing with sklen. Then same thing for precision. Precision is higher. So we'll be doing all this in our next class. Now I have a question. I will just use 2 minutes to do like a review again. I will go over something again before our time. So I have a question. I won't put the answer here again. So why, let me do it like this. Why do some models select different features? Why do some models select different features based on our explanation? Why do some models select different features? Why do some models select different features? Second, does fewer features always mean lower performance? Does fewer features always mean lower performance? And the third one, which method is best suited for this data set? Which method is best suited for this data set? And how will you approach this in real medical system? So the first question is, why do some methods select different features based on what I've explained? But I want this second question. I want someone to answer this second question. Does fewer features always mean lower performance? Does fewer features always mean lower performance? They are always answering no. This material should come before each class. No, it does not. Please, okay. Okay. Please, why? No, why? No, no, no. Well, why? The fewer features based on their different algorithm. Based on different algorithm. Due to the variety of factors, including the specific algorithm, since larger data set produce more diversified training for the model. Okay. If they are important features, different algorithm. No. Okay. Okay. Oh wow, this beautiful answer. Timbra, Timimbra. They'll send the material. They'll send it. Performance. The more features, the better. I think, though it does not sometimes. Okay. Performance depends on the type of model you use, but the larger your data set, the better it performs. Okay. 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 I should explain the code. Okay. So in nutshell, you need to be careful when we start doing our training our model next week. You need to be careful of the type of features. In one of my work, I use those four features, right? Those four features: glucose, BMI, what again? Pregnancy and age. Just four features. Then later I used three features, and still my model still predict well, still did well, right? There's something I did inside, right? And sometimes, if you have to be careful. It's just like we are supervising. People say supervise learning. You are supervising your model. There should be somebody that is supervising the model. This is how I want it, like the way you think. This is how I want it. So if you use six features, seven features, eight features, and the most important information is they are not in those features. Your model can be biased, right? Or they will be like overfitting or underfitting on your model, which might not generalize well. So most times, just pick the most important features. Pick the most important features. So it does not fewer feature does not affect low performance actually, but you need to still be careful, be very very careful with it. Then which method is best suited for this data set? Okay, this last question, then I'll do revision in the next 4 minutes. Just revision again and go. So with all the features that we have explained, Oluwole have explained, Isaac have explained, and I've explained. I've talked about forward and backward feature selection techniques, forward and backward feature selection techniques. I've talked about feature selection techniques. I've talked about feature importancy, and then which is the best method for our data set. Which method is the best suited for this data set? Which is the best? Okay, Isaac, you gave the okay. Which is the best suited for this data set we want to work with? Abraham, you need all the list for the libraries. We've shared it in the first class. First class, all the lists, all the libraries, first class. Based on all the features, which do you think is the best for this type of work? We want to work with this. Which is the best? I'm waiting for our answer. Just one person, just one answer, and I'm good to go. Fewer feature does not mean lower performance. I'm still seeing RFE, recursive, okay. Okay, regression, since we need a numerical output and we know what is okay. Age, like the best feature selection, I'm asking for the best feature selection techniques. Best feature selection technique for our work. Force selection, okay. Regression, okay. I'm not doing question. Okay. Okay. So my assignment for us is what we'll do is where we start from the not a number. So look for the best features. Just go online, look for the best features and apply it. Play with it. Okay, let me apply these features. What will you pick? Apply this feature. What will you pick? We'll apply this feature. For the next class, we'll continue with that. So in the next 1 minute, I just want to do like a recap of everything we have done. Next 1 minute. I said first of all that we have a problem statement we want to work with that won't develop a model. Then pandas for the libraries with DF. We need a data set, right? Then DF to to check for the first five columns of data sets, then tail to check for the last column, information of the data set if it is integer or float, they want to know what to work with. Then this ED of the people that have diabetes and people that don't have diabetes. You can use any data set, do the ED on it, and then bar chart, the pie chart, and then you just play with it, play along. So that's what we did. Then we did EDA last week, EDA using correlation matrix and different EDA, voice plots, pie plots, and apply mean. And for this class, we also do applying different feature selection techniques. We say we have different type of feature selection techniques, the RFE, the select key best, the four features, the backup feature selection techniques, and then applying it to our work after we have done with our preprocessing, replacing NaN is with NaN, right? So we've covered all this stuff, and in next class we now start our model training properly. That is the AI that we are talking about. Start fine tuning, start deleting, then we'll see how we can explain them, right, in our next class. We now see how we can now start applying it. When we are done training, we create a system. We develop a system for it. So the AI, the model will be working in the back end. Then in the front end, we'll be doing what we want to do. So that is for that. Thank you for this class. Thank you for joining. Thank you for following. Next class, I have gifts for anybody that will be answering my question. I have a gift for you. You are typing, I'm doing everything. I have a gift for you. But for those people that have issues, maybe with their laptops and the lights, is nothing. Nothing. I'm still going to explain again. I'll do that, explain over and over again. So thank you for this class. Thank you so much. Thank you for joining. God bless us all.